Ionic compounds. Again, write down the metal first and then the non-metal, right? So these are what we call, these are fairly straightforward ones, I guess you could say. Just remember that the metal comes first, the non-metal comes second. These are what we would call, a fancy term is binary ionic compounds, so there's just only two atoms to deal with, basically. This here, of course, this is the sodium, right? Sodium, and this was chlorine, but because it's part of an ionic compound, it has a charge, we say sodium chloride, yes? Those are the two ions that are involved. And of course, if we swapped and dropped and reduced, I don't know if we talked about that a little bit yesterday, I think. So 1 and 1, we don't write the ones, and that's how we get that formula there, right? This one here was K, which is potassium, and nitrogen, which becomes nitride, of course, potassium nitride. Again, if you look up the charges for this, that's a K plus, and that's a 3 minus, and we'd swap and drop those two, and that's how we get that formula of K3N, right? Make sure you're using subscripts, so make sure you put the numbers at the bottom, of course. Here we have some magnesium and iodide. Would be that one there. I think we did we do these yesterday? Yeah, okay. And once again, that'd be made up of a magnesium 2 plus here and an I with a 1 minus charge, right? So swap and drop, and that's how we get those. Remember, swap and drop, of course, 2 comes over and down, the 1 comes over and down, so Mg1, I2, yes? Kind of like so, right? What's next? Symbols, yeah, we did that. We didn't do this, did we? I don't know, it's been a while. We did? Okay. Holy, I don't remember doing this for some reason. Was I here yesterday? I guess that's the second question. Huh. Calcium. Well, calcium comes in a 2 plus, of course. Chloride comes in a 1 minus. Are you sure we did this yesterday? Okay. Wow. I gotta go to bed a little earlier, apparently. Eh? Swap and drop, of course. Write that, and I would encourage you to write down the 2 ions. You don't have to, but remember, we can't really mess these up because we're going to use these later on for math formulas and things like that. We need to get what we call the molar mass. I don't know if you've done that before, but we need to get molar mass and things like that. So we need to do some calculations with these as well. Plus, we need to do writing chemical equations. So if any part of this gets messed up, then the rest is probably going to be wrong anyway. All right. Sometimes we have 4 or 5 steps to worry about. We don't want to mess this part up. Okay, this is the easiest part of that probably. So swapping and dropping here, of course, 2 is going to come over and down. The 1 comes over, so CaCl2 is what we would end up with a formula there. Magnesium oxide. Okay, magnesium's that 2 plus there. O is a 2 minus. Again, in this case here, if this one's going to lose 2 and that one gains those 2, we only need 1 of each. Yes. Or swap, drop, and reduce the charges, yes? So again here, this would be MgO. Oh yeah, I remember this now because that was my joke right there. Yeah, MgO and magnesium. Okay, oxide was his name. Lithium nitride, so lithium's a 1 plus, N's a 3 minus. Again, swap and drop here, right? You know, lithium and that 3 comes over and down, so put a 3 there. 1 comes over and down, we don't write the 1, right? Again, you know, another way to think of that is, I know some teachers don't say swap and drop, but I think most of us probably do. But again, you would need, you know, if we're trying to make, the point of ionic compounds is that whatever you lose has to be what you gain. That's how they help each other out. So if you need to have, you know, 3 positives to go with 3 negatives, right? Overall, we should have 0. And that's the key there, right? We want to make sure overall it's 0, right? Good? Yeah, yeah. All right. Multivalent, okay. Again, we're going to have to use Roman numerals at times, so be aware of that. Here we go. This was, oh yeah, I remember this now. Again, 2 parts here. So the first part is iron. Iron has more than 1 charge, so we want to think about, okay, right away, when you see that iron has more than 1 charge, and if you're naming it, you probably want to put some brackets down so you don't forget, hey, I got to put a 2 in there or a 3 in there or whatever the case might be. Cl, of course, is chloride. Okay. And there's a couple options here. Some people say, we reverse swap and drop kind of thing. So kind of think about what would happen if you kind of bring the numbers back up and then switch them again. So we could take a look at that, so for example, this 3 would come back up and that would be the charge here. So that's a 3 plus, of course. And this is a 1, so that'd be a 1 minus, which kind of matches up with that. So this would be iron 3. Okay, so that's an option. You could try that if you want. That's not my favorite, honestly. I sometimes, maybe in this case, it's a little bit obvious, but I don't mind writing the 2 options out, and then saying, okay, which one, when I swap and drop, the top one, is that going to give me the right formula? And if it does, then it's iron 3, of course. If it was iron 2, I'd get FeCl2, which doesn't match up. So I know that this is the 3. This one here gets a little more complicated just because tin has more than one charge again, right? Tin has, again, I think we talked about this yesterday. This is tin something oxide, right? Sn is tin, actually. Again, do you go with the 2 or the 4? Because tin comes in 2 options. Well, if you have this formula here, if I take this 1, it's right there basically, and go up to here, that'd be a 1 minus, and this O would be a 2 plus there, right? But O doesn't come in a 1 minus, it actually comes in 2 minus according to our periodic table because it's 6 electrons, yes? So really what we need to do here is multiply this by 2 to make sure we get to 2 minus, and this would be the 4 plus. So they're multiples of one another, yes? That's not my favorite way to do that, I'm going to be honest. That's an option. If you're comfortable with that, go with it. So this would be tin 4. My option is I just write the 2 options out, and then just ask yourself, okay, when I swap and drop, if I swapped and dropped this one, it'd be just SNO because it's 2 plus 2 minus, so we swap, drop, and reduce. 2 plus 2 minus 1, 1, we're done, yes? So we don't want that because this is SNO2, of course. If I take this over and down and that over and down, that'd be a 2 and a 4, or basically a 1 and a 2, and that's probably one that's going to fit a little bit better for our compound. Again, up to you, okay? You just have to be careful with those. 4 plus 2 minus kind of stuff. What else? I think there's a 6 plus and a 3 minus, those kinds of ones you want to, or 6 and a 2, for example. You just want to be careful because, of course, you're going to have to reduce those down, right? Okay. Roman numerals. Tin 4. These are a little bit easier because they tell you basically what, if you know what tin is, which you may or may not because it might be a while, but if you know what tin is, you already know what charge you're going to use, right? Because it tells you it's tin 4. Chloride is a Cl1 minus, and we're going to, of course, swap and drop, yes? So 4 comes over, 1 comes over, and we end up with that. Copper 2 oxide, copper 2 oxide looks like that. Again, swap, drop, and reduce if you have to. So 2 plus 2 minus, so really 1 and 1. And so this would be copper 2 oxide, looks like that, okay? If this copper loses 2 again, and this oxygen gains 2, we just need this one to lose 2, this one gains 2, we're good. Okay, 1 and 1, good? Questions, anyone? Okay, we're almost done here. Now, we're going to get into polyatomic ions. Now, polyatomic ions, you need periodic tables out. Periodic tables. Polyatomic ions are going to find in the top left, kind of on the above the metals there. There's a big square, and it says basically right at the top there, table of common polyatomic ions. All right, is what it says. So a lot of these, in some cases, there's some atoms that have combined together and are looking still to gain some electrons. There is actually one example there where it's looking to lose an electron. All right. That one example, by the way, just so you know, is NH4. It's the very first one. Okay, it's called ammonium. and it's got a 1+ charge. So when nitrogen and 4 hydrogens come together, this is something we won't do this year, but perhaps next year or next semester, depends when you take Chem 20. But when nitrogens and hydrogens come together, it turns out we have one too many electrons. So we try to get rid of that electron, basically. And we get rid of it by hopefully combining it with a nonmetal, of course, to take that electron for us to kind of make it work out a little bit better. Most, all the other ones that you have there, just as an example, SO4 2-, is a bunch of atoms, or some atoms that have combined together to take in some electrons in this case. Okay. In fact, SO4, when I combine sulfur and 4 oxygens, we're 2 electrons short. So we need an extra 2 to kind of fulfill that energy level, if you want. So we want to gain 2. Okay, and that's called sulfate. Usually how it works is, usually, not always, if this is an S, that has to do with sulfur. So we look in the S section, yes? It's alphabetical, so except for the first one here, that's ammonium. But it's alphabetical according to their name, for the most part, okay? Now there's a few exceptions. You're gonna have to look a little bit like a scavenger hunt, but it'll be fine. So it goes from ammonia all the way up to, I believe, thiosulfate is the last one, all right? Which is actually, again, there's an S in there, sulfate kind of thing. So it's kind of S2O3 kind of thing with a 2- charge, okay? So it goes alphabetically for the most part. These are what we would call, like I said, polyatomic. Poly means many, and atoms. Basically, many atoms have joined together to take in some electrons, or in this one particular instance, let go of an electron, right? So polyatomic ions are made up of several non-metallic atoms joined together by covalent bonds. As a group, these atoms have an overall positive or negative charge. For example, SO4 2-. So this is back to the notes now. You're gonna have to copy a few things down here, yeah? Okay, I think you have all this, I believe. I don't think you need to copy anything there. That's kind of what it looks like. You don't worry about that too much. It's actually probably wouldn't even draw like that, to be honest. I wouldn't worry about that. Okay, don't worry about that. But that's kind of what it would look like there. All right. Oh yeah, funny. Let's see. This isn't actually. But how do I get? Oh, want to hear a joke about sodium hypobromite? Nah, bro. It's not as good as what was my MgO kind of thing. That's the formula for it, by the way. Okay, rules for naming these polyatomic ions. We always name the cation first, so that doesn't change. We always write down the name of the negative ion. That doesn't change either. Okay. If the anion is a nonmetal, change the ending to "-ide". If it's a polyatomic ion, we are not going to do anything. We're just going to write down what it is. We're going to have to find it from the list. Okay. Beware of multivalent metals. Let's take a look at a few examples. There we go. So please pay attention. So first part, of course, we get something like this here. By the way, it would look MgSO4, something like that, right? So the first thing, of course, we notice here is we're obviously going to name this because we have the formula. So the first part I look at is, of course, the metal, right? Metals always come first. So this is my metal right here. This is magnesium. Okay. That means that the rest of this, if the first part's the metal, the rest has to be the non-metal part. And I have more than one atom here. So instead of looking like, for example, in your, on the right side of the staircase there, this is S and O's, you're going to look in the top left there because there's a bunch of atoms, and you're going to find an SO4 hopefully somewhere there. And that, of course, is what? Sulfate. So you're just going to write that down, sulfate. Okay. And basically how this works is this: 2+, and SO4 is a 2-. So magnesium loses 2 electrons, and SO4, if you look on your list there, SO4 wants to gain those 2 electrons. So they work out perfectly, right? Basically one of each would work, MgSO4, okay? Good? Then we have this one here. Questions, anyone so far? This one here, right? Same thing. Well, okay, the first part has to be the metal. So I have some Al here, right? That's my metal. That's aluminum. This part here kind of has to be the rest, doesn't it? Now, you're not going to find NO3 with a 3 behind it in brackets, but you will find an NO3 there, yes? What's that called? Nitrate. Okay, so nitrate. Now, again, remember, we're going to talk about this coming up here, but those are the two ions that we're basically dealing with here, yes? Okay, and I know some of you are thinking, oh, that we did this last year, it's all good probably, but regardless, we're going to review it. Now, where does that extra 3 come from, basically? Well, again, this 1 would come over and down. We don't write the 1, right? That would be this part right here, Al1. This 3 has to come over and down, and I'd have to put a 3 there, but we need to use, if you remember from last year, I think you did this last year perhaps. No. I see this, I see, okay, we're going to talk about how to do this, but that 3 has to come over and down. We're going to need a bracket there, okay? So we're going to need some brackets. We'll talk about that in a second, I promise. Okay, right now, really, remember, they can only combine together in 1 ratio, yes? Just like yesterday. If Mg 2 plus, if Mg loses 2 and O gains 2, there's only 1, 1, right? There's only one way they're going to combine. It's the same thing here, right? Like this one here, for example, this is Fe, right? So I'm going to say, well, that's iron. What else do you know about iron? Look where iron is, yeah. Exactly, so it is what we call multivalent, or basically it has more than 1 charge. It comes in a 2 plus and a 3 plus, yes? So we have to understand, okay, well, now we got to use these brackets here again. Which one are we going to use here, right? And OH, this has to be the non-metal part, yes? And I'm not going to worry about the 3 for right now. I'll explain that coming up here. What's OH? Hydroxide. Okay, this is very, and we have to remember this. OH, it's not oxygen, hydrogen, it's hydroxide. It's in the list, find it, okay? Hydroxide is a very common, very, very common type of thing. It is for bases, yes? Hydroxide. Now, how this works is basically this. Well, I guess I'm jumping ahead here because we really don't know. It could be that one or it could be that one, yes, because we have 2 irons. And OH is a 1 minus, okay, like that. So when you swap and drop, which one's going to give you the right formula? Well, you know, again, if you did this one, the 2 would come down. We don't see any 2s there. The 3 would come down, yes? So I think we're going to go with iron 3. Okay, good. I'll explain the bracket thing here in a second. Questions? Anyone so far? We'll talk about the brackets here right away. Don't be shy, ask. All right. Okay. Well, let's go to the next page here. Rules for writing the formula. Okay. Again, we always start with the metal first, or NH41 plus because it is a positive ion. Okay. Then it's always the negative part. We use subscripts just like we did before. We drop and swap the charges. And if we need more than 1 polyatomic ion, we need to use brackets and a number there. Okay, and I'll explain that when we go through this. Okay, so the first one is sodium chlorite. You have this on your list there. Okay, so I would always start, if I were you today anyway, I would start with basically the 2 ions. And then we'll combine them together so you can kind of see them, okay? Sodium's a 1 plus. Chlorite, okay? So it starts with C. So we're going to look under the C's. We're going to look somewhere there. And probably in that first column, and in fact, I know it's in the first column, we're going to find chlorite. And that, of course, looks like what? What is that? ClO2. That is an L. Chlorine, chlorite, right? It is not an I. Do not write an I, because if you do, that's iodine. That changes everything, okay? So that is ClO2, and that charge is, of course, a 1 minus here. Okay. Now we focus on the charges, yes? Because remember, this is going to lose 1, so this sodium loses 1. Where's that electron going to go? ClO2, that all combined together is looking to gain 1, yes? So that's that group of atoms together. So this one loses 1, this one gains 1. We only need 1 of each. We do not write 1s, yes? So we can swap and drop. That one will come over, we don't write it. This one comes over, we don't write it. So we get NaClO2, yes? That one Na is going to lose 1. That ClO2 is going to gain 1. Yes. Good. Okay. Now, copper, and they're telling you that you're going to use 1, copper 1. Copper has more than 1 charge again. Yes. And chromate, again, you want to look for probably C's for the most part. Okay. And chromate, once you find it there, probably, I'm not sure, it might be, I don't know where it is, to be honest. But somewhere there, you'll see CrO4, 2 minus, like that, okay? And again, okay, we need to swap and drop. So this 1 will come over and down. I don't write 1s. And the 2 comes over and down. I will put the 2 there. So we're going to get Cu2, okay? And then CrO4. And then there's a 1 there, but we don't write the 1. All right. So let me just kind of go back here for a sec. This one, I didn't want to do it the first one just because it's 1 and 1, so it's not going to work as well. But basically what we're saying here is this. As you know, overall, these compounds have to be neutral, yes? So we have, apparently we need 2 of these, right? That's a 2 positive altogether, to go with 1 that's going to gain those 2 electrons, yes? Okay, so we have a Cu2, we need 2 of those to go with 1 of those, yes? And because I didn't write anything here, look, this is 1. This is all together, right? We can't forget that. It's not 4, there's O4, but that's already been grouped together for us. That's called chromate. CrO4 is all 1 ion, yes? Just, you can pretend to, you can call it like, you could pretend it just like copper 1, no, that's not going to work. Oxide, okay? Basically, that would be a 2 minus, and that's a 1 plus, and it's the kind of same thing there. It's the exact same, right? It's just that CrO4 is all together, right? We have to treat it all together as a little group. Yes? Question? Yeah. 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 Okay. Now, sometimes people see this and they want to reduce stuff because remember we talked about reducing, right? Swap, drop, and reduce. That has nothing to do with it. That's not the charges that we're reducing now, right? The charges that I had were right here, 1 and 2 minus. Can you reduce those? No, right? 1 and 2. If they were 2 plus and 2 minus, would we reduce them? Yes. That's different. Or 2 and 4? Sure. But this is a 1 and a 2, so we're just going to swap and drop those. All right. Okay, let's take a look at a few more examples. Is there no more examples? That's it? I got to have more examples than that, isn't it? No? Okay, we're going to make up some. Perfect. Let's see. How about this one? Calcium sulfate. Oh, we got to have more examples than that. Yeah, no. But there's got to be, because I'm sure you're going to run into this situation here at some point. Yeah. Okay. Calcium sulfate. Go ahead and do that one. Let's do some practice. We got time here. Do some practice ones there. Half an hour. Good? Yes. So calcium, we're going to do a couple because I got to show you a couple more things here apparently. I'm not sure why we don't have these examples there. Thought maybe it's on the next sheet here, but calcium looks like that. And again, I would suggest writing them out so you know what you're dealing with here. Sulfate, you're going to look under the S's, right? There's, by the way, there's sulfate and there's sulfite and things like that there, right? SO3 2 minus. This is SO4 2 minus. These are the charges now. We're looking at these two charges, and I see 2 plus, 2 minus, so we're going to swap, drop, and reduce in this case, yes? So when I combine this together, really this is going to come over, that's going to come over, but really I'm dealing with, instead of 2 plus, 2 minus, really just 1 and 1, yes? I don't write the ones, so we're going to end up with some CaSO4, yes? Okay. So we still write obviously the SO4 there. That's what sulfate is SO4. We're just looking at the charges. Where it gets a little different now is this. Let's go to this one, which would be, let's say, chromium. We'll go with 3. And nitrate. Chromium 3 nitrate. I would suggest, again, always start by writing out the 2 ions to start with. Okay. Now here's where it gets a little different, all right, and especially if you don't know what I'm doing here. But again, we're going to swap and drop, okay? So when I combine, what I usually do is kind of this, and I kind of leave a little bit of room here just to make sure. I kind of write down those 2 ions, chromium, right, and then nitrate, and then I do swap and drop. So the 1's going to come over and down. Do I need to worry about that? No. The 3's going to come over and down, yes? So can I just do, does this look right to you? Right? What do I need to have there? I need to have brackets, right? So I need to put that there, right? And it's important that you put brackets where appropriate, and where it's not appropriate, don't. And then the next thing that happens is people just put brackets in there just because, you know. But if you only need 1, you don't need brackets because there's only 1 there, right? So we need to put brackets there. And here's the reason, basically. Remember, chromium is a 3 plus, right? It wants to lose 3 electrons. This group of atoms over here, that group of atoms can take in 1 extra one, right? And again, just like before, those 2 charges do not balance each other out. So the only way to do that is, well, I need another group of those atoms, so I need another one of those NO3s to take in 1 electron. And I need, finally, the last one here, I need another group to take in 1 electron. So I need 3 groups of those, and so that's why we put brackets around them, right? Because I need basically 3 groups of those. Yes. Okay. And the little cheater that goes with that, if you want to know, is anytime that you're dealing, I wish I had the periodic table here, but I don't. Anytime you are dealing with that top part and you need 2, or you're going to put a 2 behind something, or a 3, or a 4 from that list in the top there, you're going to be putting brackets. Okay. The only time you don't need brackets is if it's 1. So if it's sodium 1 plus and you want to move that over to a polyatomic ion, you don't need any brackets because the 1 is going to be taken care of. When you write it down, that's 1. But as soon as I've got to put a 2 behind there, or a 3, or a 4, possibly a 5, you're going to need some brackets, yes? Okay, we'll just do one more here real quick. Yeah, we'll do, let's do aluminum, I don't know. No, I can't do that one. We'll do aluminum carbonate. Let's do that. So go ahead and do that one. And then I think we'll call it a day here. And again, when you're going to write down formulas, I would always maybe start with, even maybe just for today, if you're feeling comfortable tomorrow, that's fine. But for today, I'd probably start with the 2 ions that you're dealing with. So in this case here, aluminum. And it's been a while for some of us. Carbonate, so I'd look under the C's probably. Looks a little something like that there, yes? Okay, carbonate. Now that's mostly how it works, but sometimes you might not find it under the C's, so you're gonna little scavenger hunt. Okay, they're there somewhere. They're all on there. Okay, so aluminum carbonate. Well, again, I would probably start with just giving myself a little bit of space here. The 2 will come over and down, so there it is right there. I don't need brackets because there's only 1 atom, so I have 2 aluminums, right? You would never use a bracket with just an element by itself. And then the 3 comes over and down, and now I got this polyatomic ion here, so I'm going to do that, okay? Brackets and then a 3. And again, if you want the long-winded explanation here, well, that's a 3+. I need 2 of those to go with basically CO3 2 minus, CO3 2 minus, CO3 2 minus, right? 6 plus, 6 minus, right? They have to balance out. And that's where swap and drop comes from. That's how they came up with that, of course. All right, good? Okay. If you have any questions, ask, obviously. Don't be shy. That's about